Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, we all know that in the last 3 days we completely focused on mathematics only, and even we finished one of the tests as well. Now from today onwards we will concentrate on even the science chapters as well. Do you know how many chapters are going to be learned in science? Yes, if you have seen the index of your 9th standard CBSE science textbook, you will come to know that there are 15 chapters, and these 15 chapters are divided to 3 branches: physics, chemistry and biology. In physics we have 5 chapters, chemistry we have 4 chapters, and biology we have 6 chapters. Do you know the names of these chapters? Now let me tell you these chapters one by one. In physics, the 5 chapters are, the very first one is motion, second one is force and laws of motion, third one is gravitation, fourth one is work and energy, and fifth one is sound. The 4 chapters in chemistry are, the very first one is matter in our surroundings, second one is matter around us pure, third one is atoms and molecules, fourth one is the structure of the atom, and in the third branch, that is biology, in this year you are going to learn some of the interesting chapters. There are 6 chapters. They are, the very first one is, it is the fundamental unit of life, second one is tissues, third one is diversity in living organisms, fourth one is why do we fall ill, fifth one is natural resources, and sixth one is improvement in food resources. Okay, dear students, from our academy I am going to teach you 2 subjects. One is physics and second one is chemistry, and for biology we have another lecturer. Now, okay, shall we begin the class? Yes. Today let us go for begin the very first chapter in physics. Do you know what is the name of the chapter? Now I don't want to tell the name of the chapter, you are only going to guess. Okay, let me show you some of the materials. Dear students, observe, here we have some of the materials. There is a train, engine of the train, and here an object which is rotating, and just observe here the bike is moving and the ball. So I hope that you are able to guess the name of the chapter. Yes, your guessing is right. It is the motion. The name of the chapter is motion. Okay, let me go for writing the name of the chapter. Yeah, dear students, you guessed the name of the chapter is motion. Dear students, every day we see many things around us. Just to recall some of the objects what you see, maybe the buildings, schools, colleges, electric poles, houses, telephone poles. These are some of the objects, and these are fixed to the ground, right? They are unmoving. Then can we say that these objects are stationary? Yes. And there are some of the objects that you see every day, like the moving bicycle or a man riding the bicycle, a moving bus, moving car. Then we see the train which is moving, and we see the birds which are flying, right? So these are the objects which changes their positions from one place to another place. So then can we say that these objects are in motion? Yes. Dear students, there are 2 states of a body. They are, one is state of rest and second one is state of motion. So let me go for explaining you both of them. Before that, just keep observing the chart I am going to show you. Look here. Here we have some of the objects. Tree is there, house, then electric pole, the building, then the hills are there. Just by observing, you can say that they are all, whether they are at rest or in motion. Yes, as they are all stationary, you can say that they are at rest. Similarly, you can observe some more objects. Look here ship, and here is a car, here is a man riding the bicycle, here the train moving on the rails, then the birds are flying. What do you say? So, what do you say the state of these objects? You can say that they are in motion. Yes. Now, let me define what is state of rest and what is state of motion. Now, you just observe me. I am standing. Am I changing my position with respect to my surroundings? No. So, now I am not at all moving. Likewise, if a body acquires the same position in all the intervals of time, then the state of that body is said to be at rest. Got it? A body is said to be at rest if it does not change its position with respect to its surroundings. Now again, just keep observing me. What I am doing? Yes. You just observe, keep observing me, and you can say that I am changing my position continuously like this. If a body changes its position continuously with respect to its surroundings, then we can say that the state of that body as it is state of motion. So these are the two important states of a body. One is state of rest and another one is state of motion. Now let us go for getting more information about this. Dear students, here I have written the states of a body and their definitions. So you have to pause the video, should copy that. Okay, now let's move on to the next part of this chapter. It is also related to the motion of the body. Every day, again we find many objects which are in motion, but some motion of some objects can be noticed directly, but some cannot be noticed, but they can be noticed indirectly. So now let me give you some of the situations or examples. You have to identify which can be noticed directly and which cannot be noticed directly. For a boy riding a bicycle, the motion of the object can be seen directly, right? Then motion of the moving bike, moving bus, a man who is walking. See, all these motions can be observed directly. Now let me take some more examples. We all know that air is a matter. Can you see the movement of the air? Yes. You cannot see the movement of the air directly, but its indirect observation is you can come to know the motion of the air by observing the movement of the leaves of the tree and branches of the tree, and also the movement of the dust particles. So from that also we can identify the motion of the air. Similarly, we all know that in our solar system, sun is at the center, all other planets are revolving around it. Earth is also one of the planet, and around the earth, moon is revolving. We say that all the celestial bodies will move. Let us go for taking just our earth only. How do you come to know earth is moving? Then do you think that standing away from the earth, can you see the motion of the earth? It's impossible, right? Then how do you come to know the motion of the earth? Yes, every day we experience day and night. Every year we experience seasons. And every day we also see the sun rising and sun setting. All these will give us information about the earth has motion. That is, earth is also moving. Got it? So these are the two types. One is the motion of the object can be seen directly and some can be seen indirectly. So now let us go for writing those also. Dear students, here I have written directly perceivable motion and indirectly perceivable motion. Here in this chapter, the main concepts are rest and motion, which are the states of a body. Both are interrelated. Do you know how? Let me give you the example. Imagine that I am going to give you two examples. Listen carefully. Imagine that you are in a moving train and train is moving with a constant speed, and the doors and windows of the train all are closed. That is particularly your compartment. Then what do you think? Do you feel that whether you are moving? No. You feel that you are at rest. Then you will also compare your state with the state of your other passenger. Then also you will come to know that they are also at rest. Now, just you will go for opening the window. There you find many objects which are moving backward. Then you will realize that yes, you are also moving. Got it? So from this example, we can come to know that rest and motion are relative. I hope that you have understood. Once I tell, for one object, it may be at rest to its surrounding object, or it may be in motion in its surrounding objects. I'll give you one more example. Suppose you are in the lift and you want to go from ground floor to nearly 20th or 25th floor. You are in the lift. When you are going up, do you experience that you are moving? No. So you will be inside the lift. You will be at rest, and you will also see some other person who are with you. They are also at rest. But imagine you are in the transparent lift. Now, when you are going up, you can see the surrounding objects. As you go up, you will observe the objects or the persons which are outside the lift. And then you will realize that yes, you are also moving. So from this example also, we can say that rest and motion are relative. And we will also find many motions. Some can be controlled and some cannot be controlled. Example, when you are riding a bicycle, when it is moving, it can be controlled by yourself by applying the brake, even for other vehicles also. Even the hydroelectric power, see that motion of the water can be controlled and it can be used for good things. Similarly, if there are some motion which cannot be controlled, like the river flood, tsunami, so all these cannot be controlled. Now, dear students, apart from this, even we have different types of motion. Now I'll go for explaining one by one. Before that, just I'll give you the points what I explained. Please go for copying by pausing the video. Dear students, every day we come across different types of motion. Example, assume that a man walking towards east. That means he is walking in a straight line. Then what type of motion it is? It is a linear motion. Then a body is moving in the circular path. Imagine that you are riding a bicycle, you want to take the turn, then you will just go for bending. In that time, your bicycle will start moving in the curved path, and we call this as circular motion. If a body moves in a curved path around a fixed point is called circular motion. Similarly, a body, if a body moves about its axis, example, you may go for taking an example of the motion of arms of a clock. Any arm can be taken. See that there will be a fixed point and all other will be moving. So this is what we say the rotatory motion. Even the ceiling fan also, the leaves will be moving about the fixed point. That is rotatory motion. And imagine you are in the park. There is a swing. Then what kind of motion you will experience there? There will be to and fro motion, and we call this to and fro motion as oscillatory motion. And you go for taking a scale, then you just bend like this and start, you bend like this and leave. See that? If the to and fro motion, what you see, it is taking place rapidly, and we call this rapid to and fro motion as vibration. Similarly, you will also come across some of the motion of some of the objects where we find more than one type of motion. Assume that there is a slope, and at the top of the slope you are going to place the ball. Just you give a gentle push to that. Then how the ball will move? Yes, the ball will move in a straight line. It is one kind of motion. And also it will start rolling. That is also another kind of motion. So this is an example for a type of motion that is called complex motion. Dear students, here I will give you some of the examples. You have to identify what type of motions are these. The first one, here a man is pushing the object, a box, and he is moving in a straight line. We can say that it is an example for linear motion. What about this one? A rubber band is taken and it is stretched, and on leaving you can find like this, it is vibratory motion. Then a boy is kicking the ball. The ball is moving in the curved path, and we can say that it is in circular motion. Then another one, here there is a pendulum, and the pendulum is moving in to and fro motion, and this is an example for oscillatory motion. Here the earth is there, earth is rotating on its axis, and we can say that it is rotatory motion. Here is the moon is revolving around the earth, and this is an example for circular motion. Here the fan, about a fixed point, all other leaves are moving, and we can say that it is also an example for rotatory motion. But when you consider the tip of the leaves, the motion of the tip of the leaves, it is circular motion. Got it? Yes. Dear students, among these different types of motion, in this chapter we are going to focus only on two types. One is a body that moves along a straight line, that is called linear motion, and second one is a body that moves along the curved path, which is called circular motion. So now let us get more information about it. Now let me write the heading, types of motion. Please go on copying with me. Yes, these are the different types of motion. Now let us go for describing motion by taking some more concepts. Dear students, many times you come across telling the address. Suppose imagine that your friend wants to come to your house. Then he doesn't know the exact location of your house. Then you just go for giving him the landmark, that my house is nearby the Ganesha temple. It is just 1 kilometer from that particular school. In this way, here I'll give you one more example. In Davangere, if you ask the people that where is Pi Academy, many will tell that it is nearby the Lakshmi flour mill. So here the Lakshmi flour mill, what I said is, it is the landmark, and the landmark that we use, nothing but the specific point that we use to describe the exact position of an object is called, it is a reference point, also called origin. It's very important one. Let me go for writing the definition of origin. Origin is nothing but reference point, the specific point which is used to describe the exact location of an object. A specific point used to describe the exact location of an object is called origin. This origin is also known as a reference point. Here, I will give you the examples. You are going to identify which is the object and which is the reference point. Then, here is the house. Then, here is the railway station. And you will tell the address to your friend that my house is just 2 kilometers away from the railway station. Then could you tell which is the object and which is the reference point? The object is which you are going to locate. It is house. This is object. Similarly, railway station is reference point. I give you one more example. That is, as I said, here Pi Academy is nearby Lakshmi flour mill. Then here, could you identify which is the object and which is the reference point? Nothing but the landmark. The object is Pi Academy. It is object. And the Lakshmi flour mill, it is called reference point or origin. Dear students, here we are going to take some of the quantities which can be measured. For example, the length of the board can be measured. Its area can be measured. The weight of an object can be measured. So, time can be measured. So, these are the measurable quantity. Do you know what we call the measurable quantities in physics? Yes, you are right. They are called physical quantities. The quantities which can be measured are called physical quantities. In physical quantities, there are two types. I go for taking a simple example. Look at it. The very first one is the time. If we ask the time to anybody, they may, in general, they may tell that it is 7 o'clock or 7:30 or 8:35, like that. Here I write 8:35 or this is called magnitude. And does it have any direction? No, time has no direction. Is it possible to say that it is 2 o'clock towards east, 3 o'clock towards west? It is impossible. So it has magnitude only. Any physical quantity that has magnitude only is called scalar quantity. This is first one. Scalar quantity. Once I repeat the definition of physical quantity that has magnitude only. Next, second one. In your previous class, that is in 8th standard, you have learned about the chapter called Force and Laws of Motion. So here, assume that a person is exerting the force on a box. About 10 Newton of force is applied. It is force, its magnitude is 10 Newton. Can we tell the direction? Yes. He is pushing the box away from him. That is the direction. Hence, here force has both magnitude and direction. Hence it is an example for another physical quantity. It is called vector quantity. Once I tell you, a physical quantity that has both magnitude and direction is called a vector quantity. Example, it is force. Likewise, dear students, in this chapter we are going to learn some other physical quantities which are very familiar. Let us go for understanding these one after the other. Okay. Dear students, in this chapter, as I said, we are going to learn some of the important physical quantities. For each, I am going to take one example. Here, imagine that a boy is moving to the school from his house. See, this is his house, and here is the school. From house to his school, he can go for with a different path, but he has chosen this is the path. This is the actual path on which the boy will travel, and when you go for finding the length of this path, and this is called distance or distance traveled. This is the first physical quantity, distance traveled, the length of actual path traveled by a body. The length of actual path traveled by a body is called distance traveled. Wherever you go, if you go for finding the length of that particular path, it is considered as distance traveled and is denoted by the symbol small d. And the distance covered by a person can be found out by a unit. That unit is meter. So this is SI unit of distance, that is meter. We go for different units. Kilometer can be used, centimeter can be used, meter can be used, but internationally accepted unit is meter. Then what type of physical quantity it is, whether it is scalar or vector. When a person is traveling to some distance, then here you cannot show the particular direction. See that it goes here straight, then again it takes little bit turning, then again he takes turn here. You cannot say the particular direction. Hence we can say that it has only magnitude but no direction. Therefore, distance belongs to a scalar quantity. It is a scalar quantity. Now, one more information. As I said, the distance can be covered from school to the house with different length of the path. You may go on this path, there may be another path like this. So hence we can say that the distance between two given points may be same or different. So here I write distance between 2 points may be same or different. And the distance covered by a body can be measured by using a device that is called odometer. Distance it is measured using the device called odometer. It records the distance covered by the vehicles. In most of the vehicles you might have observed that where you are going to put the key to start the vehicle, there you can find a circular shape in which scale will be there. It is odometer. Now I will show you that figure in the later part. And another important thing is distance. If a body is at rest, could you tell what is the distance covered by it? It is 0. Then if a body start moving and takes the final position, then you can find out its length. And this length will always be positive. Hence we can say that distance may be 0 or positive. So I can write it as it may be positive or 0. Here let me show you the odometer. It is a device used for measuring the distance covered by the vehicle. Here it will be like this. This is odometer. You can observe the scale, and here whatever numbers are there, 0, 10, 20, 30, 40 up to 150, that shows the speed. But here you can notice that the numbers 1, 2, 3, 6, 0, then 5 is there. It indicates the distance traveled by the bike. And on the other side there will be another one, which is fuel indicator. Now here, when a boy is moving from his house to the school, there will be many roads. He will go on those roads. If you go for finding the length of the path on which he has moved, it is called distance. In between the house and the school, there will be many other buildings may come. We won't consider, suppose you go for taking the direct distance from house to the school, that direct distance between the initial position and final position of a body is called displacement. This is the second physical quantity, that is displacement. Let me tell you the definition. Displacement is the direct distance between, or the least distance between, the initial position and final position of a body. Displacement. And displacement is denoted by the symbol S. Look here. Here, assume that this is A is the initial position of an object. It travels like this. Then B is its terminating position, that is final position. Here we are not going to consider the actual length of this part. Instead, we will consider the direct distance from A to B, and we call this as displacement. And even its SI unit is also same. The displacement is measured with a unit called, it is meter. And another one is, for displacement we have magnitude. You may take for example that from the direct distance from A to B is about 2 km, and on B to A, that is also 2 km. There is magnitude as well as direction. A person will move from A to B or B to A. Therefore, it belongs to vector quantity. Question can be asked like this: why is displacement called vector quantity? You can say that it has both magnitude and direction. You are right. It is a vector quantity. Now, the displacement between 2 points. See what is the displacement is 2 km. The displacement between either from A to B or B to A, it is always same, will not be different. So we can write displacement between 2 points is always same. Then displacement negative, even it may be 0 also. Suppose a body is at rest. What is its distance? 0. What about its displacement? That is also 0. Why it is 0? Because its initial position and final position is same. That is why the displacement is 0. It may be positive. When we start moving forward, then we will go for taking displacement as positive from his initial position. If he comes back, then from his initial position we take the displacement as negative. Hence we can say that the displacement it may be positive or negative or 0. It may be positive, negative or 0. Now here just I will show you the picture with respect to distance and displacement. Look here. Here A is the initial position of a body. This is the actual path on which a body is moving. Finally it reaches to the point B, that is called final position or terminating point. If you go for finding the length of this path, which I have shown with a red color dotted line, it is called distance. When you go for taking the direct distance from A to B, and this is called displacement. Now just observe it. Look here. Here I have taken a situation in which the body travels in a straight line from A to B. Then what is the distance from A to B? If it is 5 km, distance will also be 5 km. Then B to A, that is also 5 km. What about the displacement? That is also 5 km. Why? The magnitude of distance and displacement both will be equal if and only if a body moves along a straight line. Now here also you can notice that the displacement of a body from A to B and distance A to B or B to A both are same. Clear? Okay. Now in the examination they may ask you a question that write the differences between distance and displacement. So in such case you have to make two columns. Don't write like this separately. You have to make two columns. One column for distance and second column for displacement. Then go for writing the differences one after the other. First definition. In distance, what you will write? The length of actual path traveled by a body. Then displacement. It is the direct distance from initial position to the final position of a body. Second one, in distance, the second point is it may be positive or 0, whereas displacement it may be positive, negative or 0. Next, in case of distance, the distance between 2 points may be same or different, whereas in this case the displacement between 2 points is always same. Then in distance it is a scalar quantity. Displacement it is a vector quantity. So these are the differences between distance and displacement. And one more thing I told you, that distance and displacement both are equal if and only if a body moves along a straight line. And another important point can be asked like this: what is the similarity between distance and displacement? You can come to know that what is the SI unit of distance? That is meter. Displacement, that is also meter. This is similarity. Now let us go for taking some of the numerical problems that are given in the textbook. They are very important. I'll go for solving one by one. Before that, you have to copy these points with respect to distance as well as displacement by pausing the video. After copying, again you come back. Dear students, just we shall go through some of the numerical problems with respect to distance and displacement. Here they have given the length of a path on which a person moves. Okay, here they are given 0 kilometer, 5 kilometer, 10, 15, up to here 20, 25, 30, 35, 40, and it continues. And the different position of a man is given. It is A, B, C. Observe the question. If a person start moving from O, from here, and reaches C, comes back to A, then what is the distance covered by him? It is very simple. He starts from O, reaches C. That means the distance covered can be written as O to C. Then from here he comes back to A, that is CA. Then could you tell the distance from O to C? It is 40 kilometers. Then C to A, look here, difference is 5, 5, 5, 5, 5, 5, 5, 10, 15, 20, 25. So now, what is the total distance covered by him? 40 plus 25, it is 65 kilometers. This is the distance covered by man. Similarly, it may be asked in different way as if we start from A and reaches to the point C, comes back to A. What is the distance? Distance from here to here, and that is AC plus CA. A to C, how much is there? Count it. 5, 10, 15, 20, 25. Again, 25. 25 plus 25, 50 kilometers. Now, what is the displacement? Displacement will be 0. Why? Because the initial position of a person was A and the final position was also A. The least distance is 0, hence displacement is 0. Here we have another statement. This is also very simple. Observe. A person travels 8 kilometers towards west and takes left turn, travels 6 kilometers. Then if it is so, what is the distance covered by him? And also, what is the displacement from his initial position? See, this is the problem related to direction. Hence, here, for the sake of understanding, here I am mentioning this is north, this is south, this is east, and this is west. Now, look here. A person travels 8 kilometers towards west. This is his initial position. He covers 8 kilometers towards west. You call this as O, this as A. Then he takes left turn. Left turn means he is moving from here on his left. He moves like this. Covers 6 kilometers. If it is so, then call this point as C. Then what is the distance covered by him? The distance is O to A, then A to C. 8 plus 6, it is 14 kilometers. And even they have asked displacement from his initial position. This is his initial position and C is final position. You are going to find out the length of CO, which represents displacement. Let us go for answering one by one. Here, first one for distance. Distance, we can write D is equal to, his initial position is O. First is moves from O to A, that is OA. Then it takes left turn, moves from A to C plus AC. What is OA? It is 8 kilometers, AC 6 kilometers, total 14 kilometers. This is the distance covered by him. Then what about the displacement from O to C? Then could you tell what type of triangle it is? It is a right triangle. If it is right triangle, Then what do you call the side opposite to right angle? It is called hypotenuse. You are going to find out the length of the hypotenuse by using the Pythagoras property. So here I write in triangle OAC angle OAC equal to 90 degree by Pythagoras property. You can write OC square on hypotenuse is equal to sum of squares of other two sides, AO square plus AC square. AO square plus AC square. What is AO? It is 8. AC, it is 6. Then what is 8 square? 8 8s are 64. 6 6 are 36. The sum is 100. OC is square root of 100. OC equal to 10. So it is 10 kilometer. This is the displacement. Got it? So we have some more problem. Let us go for solving. Observe it. Here we have one more numerical problem, but it is related to a circle. A particle moves in a circular path. Here I draw a circle. It is moving in a circular path of radius 7 centimeter. The distance from center to any point on the circumference of the circle is radius. It is 7 centimeter. If it is so, then if it completes a round, one round, if it with the initial position, call it as A, and if it completes one round, that means it comes back to the same position. Initial position is A, final position will also be A. If it is so, then we have to find out the distance and displacement. Here I write, let the initial position of a body or particle be A. Then look here, it start moving from here and completes one round. That it completes one circle. What do you call the distance around the circle? It is nothing but perimeter. So then what is the formula used to find out the perimeter of the circle? Nothing but circumference of the circle. It is C is equal to 2 pi r. Then what is the radius of the circle? It is 7 centimeter. Here I write r equal to 7 centimeter. Now you are going to find out the distance. So distance can be written as C equal to 2 pi r. 2 into what is the value of pi? It is 22 by 7. Radius is 7. 7 can be cancelled. 22 2s are 44 centimeter. So on completing one round, the distance covered by 8 is 44 centimeter. Similarly, you are going to find out the displacement. If you want to find out the displacement, you must also know the position, final position. Here initial position is taken as A. What will be the final position after completing one round? That will also be A. The final position of the particle is A. So displacement is equal to 0. Here you can write the reason, because initial position and final position are same. Initial and final position of the particle is same. Now let us come to the fourth problem. Here you just observe, it is also of same type. A body is moving in a circular path of radius 14 meter. Here I draw a circle. And what is its radius? Radius is 14 meter. I call the center of the circle as O and in its initial position as A. Then find the distance if it completes 2.5 rounds. See that? 2.5 rounds. Here it completes one round. It comes to A. Second round. It comes to A. Third round. In the third round, 2.5 means B. So B is the final position of the body after completing 2.5 rounds. Here I'll write it. Let the initial position be A. Then final position after completing 2.5 rounds is B. With this we have to find out the distance. Just we have come to know if it completes one round, that will be equal to circumference. Circumference formula is, it is 2 pi r. It is for distance to be covered for one round. Here they are given 2.5 rounds. Hence we can multiply 2.5 into 2 pi r. This is the distance covered by the body after completing 2.5 rounds. Then they have given the radius. It is r equal to 14 meter. Here let's move on to calculation. Here 2.5 mixed fraction is there. Convert this into improper. 2 2s are 4, 4 plus 1 5, 5 by 2 into 2 pi r. 2 into pi, where pi is 22 by 7 into r is 14. 2 get cancelled. 7 ones are 7, 2s are. Now 22 5s how much? It is 110. 110 2s are 220. 220 meter, that is the distance covered by a body after completing 2.5 rounds. What about second one, the displacement if it completes 1.5 round? If it completes 1.5 round, just observe here, from here to it starts from A, ends to the A after completing one round. 1.5. The position of the body after completing 1.5 round is B. Then displacement is direct distance from initial position and final position. That is the distance of AB. How much it is? Here 14 plus 14. 14 plus 14. It is 28 meter. 28 meter is the displacement. Here I'll write second one. Let the final position after completing 1.5 rounds be, let it be B. Then displacement is equal to AB. It is nothing but diameter. Diameter is 2 times of radius. 2 into, what is the radius? Radius is 14 meter. This will be 28 meter. Hence displacement is 28 meter. Got it? So you have to pause the video and should copy all the problems what we have solved so far. Total 4 problems are solved. Okay, listen to me. Dear students, before concluding, let me remind you one important point. Whatever the syllabus we are covering, please work out on the same day itself. Don't keep anything pending. And in today's class, what we have learned, all are important, particularly the differences between distance and displacement. Second one, reference point. Third one, the numerical problems. In addition with that, one more, we have come across 2 types of physical quantities. scalar and vector. You have to practice these questions. So with this, let us stop. Thank you. Let me continue in the next class.